Okay, please sit down. And now we have another presentation. This presentation will be by Yury Tsarev and Nuno. And it's from alert fatigue to self-healing, building an AI-enabled control planes in banking. The stage is yours.
Thank you so much. Thanks everybody for joining today. I'm Yury Tsarev from Abound. Abound, we are creators of Crossplane, and I work as principal solutions architect as a customer-facing team. So we have a privilege to work together with the largest organizations on this planet and help them with Crossplane adoption. And together I'm with my friend Nuno, who is leading one of such a big organization.
Hello everyone. Good morning. So Nuno, head of public cloud at Millennium BCP, which is a bank in Portugal. Most of our customers, B2C customers, are on mobile devices. So we kind of have interesting things to fix with what you're going to see. And exactly why did we come up with a presentation that has the longest title? Because we wanted to stop doing this loop with just people, because we wanted to focus on build instead of run. We do a lot of signals. We do a lot of human reasoning. We do a lot of human decisions, and sometimes reconciliation works. But while we're doing that, we are not building the next best thing, which is kind of what we like to do. So we thought, why not do this differently? We are challenged, being a bank, with this topic of operational resiliency. Those of you that work in regulated industries know that there's a big push in these topics. So, a service going down nowadays is a board-level thing. There's EU regulation that ensures that we do a lot of visible, properly managed, auditable, and all of those interesting and very cool IT aspects of the thing. And regulators really ensure that we can withstand, respond, and recover from the sort of disruptions. And having to cover all of this and do build, well, maybe we want to offset that burden of manual operations to something else. The challenge of doing that is matching these sort of requirements from organizations that enforce a service pattern with things like auditability, properly defined runbooks, tile management, alert structure, prioritization algorithms, and all of that stuff that we traditionally would put on humans. Someone said in a presentation yesterday that they had to fill out a lot of forms to get production data. That's a reality, How to do less human and still cover all of those challenges. Even because, this is something most of us, I think, understand simply. When you do a lot of alerting, oh, we're cloud native, we do observability, we push stuff, we do shift left, we do shift down, we do all of those cool stuff. And then you get 60, 70, 80,000 alerts configured across your platform. And someday at 2 a.m., things start popping up. and the guy that's doing support at 2 a.m. can't handle it. No, obviously. It's all nice and good to say we've covered all of the functional, technical, whatever requirements. That's a different thing to fix it in 5 minutes when it's 2 a.m. And honestly, most of the times, as we might know, it's typically kind of the same patterns. It's new deployments, it's scale issues, it's unavailable zones or regions, or, as we all know, it's always DNS. We need to get this guy a bit more sane, with a bit more tools, with a bit less worries to handle. So, because for the last 6 years, we've been very focused on control planes and implementing platforms and running global control planes, distributing things across many, many places in Europe, it's simple for us to say, let's put that in the control plane. And because we use Crossplane, okay, let's use Crossplane to help the guy. Crossplane is doing reconciliation loops on most of our infrastructure. The mental hop from a reconciliation loop to an event augmentation loop, to an infra validation loop, to an information gathering loop is more a mental one than an implementation one. Because if you're checking a resource, going after drift, you may eventually want to do a couple of other things. With this premise, we were very interested in this feature in Crossplane v2, which are functions. Especially because in that scenario where we are pushing 60, 70, 80,000 alerts through pipelines and trying to make use of that to trigger action, the fact that now in Crossplane we can schedule function execution, we can watch for events, or we can even fire one-off functions, means that at the resource context, we can do additional stuff. The challenge with this sort of tooling now becomes, what do I want to do? Where's my trust boundary? Where do I draw the line? I mean, we're a bank, right? Let's not put everything in AI on a first turn. Additionally, the fact that with Crossplane v2, this can be done at the namespace level means that we can do different things for the same resource type for different internal customers. So, imagine that we have different contract levels with different teams. Team A has a very critical service that needs whatever. Team B has business departmental services that don't need to be up at 1 a.m., for instance. Those service levels are baked at the namespace level and are also used when we run these functions to actually determine, do I want to do anything now? Can I wait for 9 a.m. for when the next guy comes into the office and can fix it with a bit more time, for instance? And mixing these two things together means that we become more efficient. We don't take the guy out of the loop. We choose and help him do it a bit more efficiently. So, Yury, do you want to show what this means, and then we'll drill into actually the how of it?
Yeah, let's try it out live. And sorry, I'm gonna sit again as yesterday. This conference spoils me. I'm gonna sit like a boss. Hello. Am I hearable? Good? I don't see terminal because okay. So maybe first thing first. Who is familiar with Crossplane in general? Nice. Who is familiar with Crossplane V2 capabilities? Pretty cool. And who is familiar with V2 operations and operational functions? Nice. So the demo gonna be useful. Thank you. All right. So what we have first? We have 3 Azure caches deployed as a custom abstraction for the bank, right? One is just for end-to-end test, and 2 are going to be our demonstration material. The implementation is not super important. It's like Azure cache with associated networking resources. It's not the main core of the story. So imagine like it can be any other infrastructure primitive. What we're going to use for injecting AI-enabled operations is a new thing called operations and operational functions. So what we are running here is a set of watch operations that are doing like a different stuff. Cost analysis, resource diagnosis, optimization, remediation. We will go through them gradually all together, step by step. So if you look at the associated operation YAML, right? So what to look at? Crossplane watch operations is new V2 resource. It's going to watch the specific resource that you specify. In this case, we specified the cache, again, custom abstraction for the bank, and we're matching the labels. So it means that on a cache custom resource, on a composite resource, there should be a label to activate its operation. So pretty straightforward. And within that operation, we are going to use a bound function OpenAI that is capable to operate in operational function code path. We have a composition functions. You remember like that composes a standard set of resources, and operational function that can act within the operational scope. So in this case, we are using OpenAI, and just in case we comply with the bank regulation, and we are running custom OpenAI endpoint within Azure. So that's how we integrate, and we actually not sending a direct request to anywhere. So it's very fine-grained, kind of almost from Azure standpoint, air-gap deployment, let's say. We have a system prompt, and we say to this operation, like you are a resource diagnostician, and you're going to take care of Azure Redis platform, and we have a pretty verbose user prompt, like how you can how this minimalistic operation, AI-enabled operation, should act on the specific resource, and what it should do in case of different scenarios, right? And the important part that it is able to patch only this specific cache that is selected by the associated watch mechanism, right? So we have this thing in Crossplane called required, or formerly known as external resources, and this way, this AI-enabled operation is super safe. It can act only on the cache and can patch the associated cache resources only. So that's roughly how it works, and we can see it in action right away. So once again, we have a cache. We have this cache that is stuck, right? So we can get this demo stack cache one. We'll pop it to a queue for visibility. So something is happening there. And for the integration, remember the watch operation, the AI-enabled is there. So it means that watch operation will be triggered whenever the resource has some event or update in the spec. So I have an associated wipe-coded demo script that can help me with the demo flow. So before we have a stack resource. We can use a kube control, as I did, to look at it like, what is happening, and we need some operation experience to figure out what is wrong with that resource. But if we use AI, and I will use a demo after, then we can see that there is a special annotation that was already set by the AI-enabled operation in this case, and it has a diagnosis, right? So now we know, like if AI figured out for us some internal knowledge that ARD IDs should be actually properly set. So once again, we can look at the spec, right? And yeah, ARD is missing there, and there is an associated diagnosis annotation is around, right?
Let me just add one thing.
Yeah, please.
So the guy at 2 a.m., when he connects to the cluster and does get, he already has a message telling him what's wrong. He's not going to do diagnostics. He's going to validate SVRs. He's going to fix it. That's stage one.
Exactly, great point. So in this case, we have like the form of this intelligent assistant. So it's effectively kind of read-only mode. It just sets the annotation on a cache spec. So it didn't act on it, right? So we have advanced version of the operations that can actually auto-remediate stuff. So the principle is simple, is very similar to the first one. Watch operation, match labels enabled, and it also filters for allowed remediation true, so we are in full control. So if we don't want AI to act on that resource, we just skip this label. And if we look at the prompt, right, the same function OpenAI, system prompt, and we just instructed how to modify the resource in the specific set of in the specific context and how to patch it properly. And again, it has a Crossplane integration, how to return this set of required resources and what associated engine should do afterwards. So, okay, let's go to the remediation stage. And to remediate, what we need to do is to set the label, right? This enable auto remediation. So my script is going to set the label on the resource, and effectively AI operation got immediately triggered because it's watch operation, it's watch for the associated change of the resource type, and the thing was auto remediated, and it puts this audit annotation that it did its job. We can obviously, and we should, double check that it's true, and we can double check the auto-remediation annotation, and we can double check the spec, and we see that ARD ID, this internal identifier, was properly fixed by AI in this demo mode. So now it will take some time, but it will reconcile itself, and it will be fully fixed, right? So that is example of automated intelligent assistant and intelligence control if we want and allow AI operation to patch the spec. Now, based on this pattern, we can do some interesting stuff like cost analysis, for example. So in this case, we have another demo costly cache, right? And before AI, what we can do, we can check the spec, and in its spec, we will see the SQ of extra large, and we don't know as an operator, is it justified or not. So we need to get this knowledge somewhere, maybe from the wiki, maybe call Nuno, right, and ask if it's reasonable enough. So we have to do some work. In case of AI, we have a helper in the form of another set of AI-enabled V2 operations. And now when we trigger it by setting yet another label, of cost analysis, we telling the operation to react, and we getting this cost recommendation. So if we check the cache, which is demo costly, right? We get the YAML, we pipe to a queue, and we check what is going on. All right, so we have a cost recommendation. Again, it's a read-only, right? So this intelligence assistance patterns that it's not acting, but just recommending via annotations. And we have a spec that is SQXL. Okay, so we still running extra large, but this AI machinery says like, it's better to downscale to save some bucks. Let's do it, but not manually. We have another operations that can do the optimization for us. So we tell it cost optimize, we setting the label for allow cost optimization, and it's gonna patch the spec accordingly. So if you double check that stuff, first thing first, we checking if the optimization, cost optimization happened, so patched from, it's actually proceeded, right? So it went from XL to L and to L to M according to the prompt. Now it's already patching, downscaling to the next resource size, instance type. And it works exactly the similar manner. If you look at the cost analysis, this is read-only one, right? So we're matching the labels and we're telling the prompt how to operate it. Here we kind of hard-coded the logic, right? But we can theoretically get it from some external resource from the bank, right? How to imprint the logic. And for cost optimizer, that's the one that is reacting to the LO cost optimization true and actually enables enable to patch the resource and modify the SQ target. So that's it for the demos. Just a quick recap. We went from intelligent assistant to intelligent control, and we have a specific use case of cost optimization also utilizing these two patterns, right? So it's just an FAA, as you can inject only required prompts into this V2A operations. You can use function OpenAI, in this case. We also have a function cloud. If you have a local model with OpenAI endpoint, it's also possible. We have a webinar around it. So it's very integratable, extensible, and you can apply this pattern in many situations. And the most important part is that you can test it. And whenever you trust it, you can promote the assistance to control, and everything is under your operational spec, operational knowledge, and you have a minimal amount of surprises when you testing these patterns, these operations and prompts gradually. So I think that's it for the demo. Nuno, stage is yours again, and slides as well.
Quick comment on that last scenario. That's called cost optimization, but if it's looking at connections and memory consumption metrics, you could also call it right sizing, because it scales down, but it can also scale up, obviously.
Yeah, you want to recap on that slide, like what happens there, right? So
yeah. So we are gradually moving from what's in the slide called stage 2, intelligent assistant, where we put a lot of annotations on resources for people to know what's happening instead of having to go at it, to, in some cases, fixing stuff before you get there, like on the remediation story. So operations that we think are not too critical, probably you don't get paged, or if you do, you're validating the fix. And finally, right sizing, both on scale-down stories and on scale-up stories, is something that's pretty relevant. It's faster to have a watch operation do that for you than getting someone to connect, to check, to scale. So basically, it's around bounding AI reasoning. We are not using big models. We are using small models. We are using those models with small contexts. Exactly what's defined on the watch operation, and it's being triggered by the same control plane that's checking resources. So reconciliation and operations end up being also done by the control plane. Of course, you've seen in the demo a simple way to keep evidences. We have to be a bit more complex than that to actually have the proper auditability trail, but the story is around this. And so, how do we keep it safe? Schema bound. We don't let AI run along the cluster and get whatever it wants and do all of that. No, we scope the problem before passing it on to some LLM, or in some cases, SLM. Policy constraints ensure that even if something wants to step out of the box, it gets denied. And we have no issues with starting small, because we think the story of providing information when you get to the resource is already a pretty powerful story. Having a best guess on the root cause of something is pretty valuable. And of course, audit trails, that's our life. And why do we look at local models, small and large? There's a whole sovereignty story, sure. But more than that, cost efficiency, latency, if we can keep if we're supposed to keep the service up for us, the models are just another service that we have to keep up. It's cattle, it's not a special thing that we subscribe somewhere, it's just we have the hardware, we run the things. It's an upfront cost instead of something we have to check every week or every month of how much tokens we're spending wherever. And of course, you've seen the speed of the watch operations. That's really faster than having someone get into the cluster and do things. That's faster than having an event-driven automation outside of Kubernetes. That's faster than cron checks that we would typically have before this. So, what changed? We can talk a lot about what changed, what are the results and all that, but I think the most significant thing is people are less afraid of connecting to an issue. When you get an event and you need to fix it, you need to diagnose and fix it, people are less afraid to connect because they expect the context to be there. It's not like you don't have to think for sure. No, you have to look at it, be aware of your business knowledge, IT and all of that. But you have the rest of the context there. Sometimes these operations are designed just to add additional information. But that beats you going after stuff. So, start deterministic, put boundaries in there, keep it small, by choice, not by cost or whatever. Do watch triggers instead of pulling. Run it locally if that's your story, if your market, if your business supports that. And proof changes. This, more than a story of implementation that's now enabled with functions on Crossplane v2, it's more a story of shifting value. Sorry, it's always this sort of thing, but it needs to be said, because as soon as we started showing how we were fixing stuff faster, was simple prompts, that enabled a lot of cool stories after this one, and this is important. So what's next? Sure, more. No, let's do more resource types. Let's do more complicated decisions. Let's do more stuff in general. But let's do it a bit more fine-grained and improve, for instance, that story of supporting different customers in different SLAs and all of that. So the takeaway that we would like you guys to, well, take with you is this one. It becomes safe in production when it's governed, it's bound, there are guardrails, and it's auditable. We have no issues running it like this. And there's code if you guys want to check it out.
Thank you so much.
Okay, thank you very much. And we have some questions here.
Got to read it.
The first one is who gets fired when auto remediation deleted prot database?
We don't delete databases.
So you're saying when it happens, it just shouldn't have happened. And
No.
It cannot happen in this scenario.
It's impossible to delete databases.
ChatGPT has led several young people to suicide. You're saying that it just should have better guardrails.
Yeah, so in this case, VV2 operation has a very constrained abilities to do stuff, right? So it just doesn't have an ability to send the deletion verb because the core deterministic part will not accept it. So that's the core of it. It's just like even if it want to, it wouldn't happen. That's it.
And on that one, there's an additional guardrail, because if you actually are able, even as a human, if you're able to send a delete, what the Crossplane composition does is it just removes access and doesn't delete the database. Because, man, who wants a database deleted, right? Leave it to a human.
The question is, this has already happened. It's a fact.
Not with Crossplane.
But to your point, you know that very famous sentence that says computers don't get blamed for management errors?
I wanted to add this sentence, and it says, victory has many fathers, but it defeated an orphan. So
Yeah.
who gets the blame? Who ends up with the bag?
It's always,
I will rephrase it. Do you add an owner to the service, or who's responsible into the metadata, or it gets decided who's fired?
it's always the service owner.
Okay, service owner.
No service is owned by anything else than a team of specialized people. And if they want to use AI, sure. If they don't feel like they can use AI, sure as well. They need to find out other ways to implement the service. I'll read the other one. Does the cost optimization operator provide any benefit for situations where HPA VPA can be used?
I think I know who asked this question.
Yes. But there are a lot of different answers here. If you're just doing plain vanilla HPA, for instance, sure, yeah. But maybe you want to use CADA for that, and you want to touch the CADA resource instead of just doing standard HPA. If you're talking about cluster scale, yeah, but maybe you want to use something that has a more complex logic than a LLM to do a cluster scaling. Is it possible? Yeah, sure. But no, pick your poison.
Yeah, and the important point is that we don't want to replace the deterministic logic like CADA provides, right? So it's like it's amending the probabilistic decision making to the story, not definitely replacing it. So you can mix and match.
Yeah. And another question, when remediation does direct changes to a Kubernetes resource, how that matches with whatever you use to define the desired state somewhere, GitOps or other? Yes. Welcome
Right. We get this
to
a lot.
GitOps hell. Well, again, it's a matter of visibility, at least for us. That's the best we can scope it. So if you auto-remediated something by changing its definition, maybe that AI function should pause that flux reconciliation, for instance, in our case, but in a way that someone at 9 a.m. has a message to fix it. Someone needs to do a PR if that change actually made sense, but no way is AI is going to be approving PRs, sorry, no. We have someone fix it afterwards. No, service is up, issue is mitigated, let people clean up the mess afterwards.
Yeah, practically you can skip this desired field from the like relaxed in GitOps scenario. And also you can teach your function, operation function, to create this PR, not approve, but create. And then you close the GitOps loop as well in automated way, if you like.
Okay, guys, thank you very much for your presentation. It was really interesting. And now we will have another presentation. Thank you very much.
Thank you.